Hi everyone, I'm here at NDC Sydney at SSW TV studio. We're having great time and I'm joined with Priyanka.
Hi guys, thank you for having me.
Yeah, and what we're going to talk about today is you had a talk about energy analytics for AI sustainability.
Yeah, that's right.
And you talked about digital twins and sustainability and how do they connect together?
Oh, that's a really good question, right? Because at the face of it, sustainability and digital twins are like two different topics. But what we intend to do right now, because with all the buzz about Microsoft Cloud for Sustainability, where it provides you a platform for actually recording and reporting your greenhouse gas emissions. Well, what do you do with all that report? You need to have some takeaway from that, right? Some actionable insight. And let's say we know that one of your facilities is causing a lot of emissions. So how to reduce that? And this is where the action item which we now need to take to sort of zoom into that particular facility, zoom into the machines in those facilities that are probably contributing to deviating from your emission goals, is where digital twin comes in. So sustainability is giving you a bird's eye view, a report on your health, your carbon emissions, whereas digital twin will now empower you to delve deeper into each aspect of your enterprise, your facility, your organizational unit, each and every machine inside your facility, and tell you how it operates, the levels at which it is causing emissions. And it becomes more interesting because digital twin will now be able to give you that power for not only reporting real-time insights, but also doing predictive analytics, like what is the optimum level at which I should operate my machines for the optimum product yield. How do I reduce my waste? What are some of the predictive maintenance things which can happen, at what time I should probably well in advance predict the maintenance for my machine parts so that they keep on operating at an optimum and maximize the output. So these incrementally, right? So as you can imagine that when my machine is operating at its most optimum and it's giving the maximum product yield, it automatically results in lesser emissions, in more optimum performance, and that contributes to your sustainability. So this is how they are correlated. This is how these two aspects are correlated.
Yeah, so that sounds really interesting. So essentially, if you find a spike in your production, you can essentially say, it's this factory, and then you can reduce it to a specific machine,
Right.
maybe even, and then say, okay, there's something wrong with this particular machine and fix it up, or
Correct.
even figure out over time how to improve it. So that's amazing. And do you see how this is going to go forward? Like, do we have any AIs that maybe can figure out if we can replace a machine with a newer model or change the process of how we do production to reduce the emissions?
Yeah, definitely, right? So that is at the next level itself. So where, so digital twin typically, as you can see here, are at 3 levels of maturity. So let me quickly bring out the digital twin, right? So here, as you can see, the digital twin, there is a physical engineering twin itself, there is an operational twin, and there is an intelligent twin. So at these 3 levels, so when it's just a physical engineering twin, it is like a digital replica of your physical asset. Then once you start monitoring it, it becomes an operational twin where you sort of get your time series analytics and root cause analysis sort of thing. And once you have sufficient real-time data, streaming data, then you can convert it into an intelligent twin where, as you rightly said, right, I can probably now simulate what would happen if one particular valve was malfunctioning, one particular piston was misfiring, one particular turbine just stopped working. And I can do those digital simulations without even physically dismantling my machine. And that could be, some sort of revolutionary next step for mechatronics or robotics, probably.
So that's very interesting. You mentioned that you can basically take apart your digital twin. Would there be difference between different kind of digital twins, between different kind of machines, maybe fidelity of how well the digital twin represents the machine?
Yeah, definitely, right? Because you can have a lot of permutations and combinations on the digital twin, the digital representation of your physical device. But when it actually comes to your real life physical conditions of temperature, humidity, even probably a slight breeze blowing and how it sort of intervenes with your processes is a different ball game altogether. You can try to model your digital twin and simulation as close as possible to your physical world, but then there are certain uncertainties which can be accounted only for once you're operating in real life. But that's not to say that this is impossible or there's a lot of deviation between your digital and your real life physical processes. You can be as close as possible, and those few probabilities, uncertainties can be certainly ironed out.
So that's very interesting, because that's essentially what it means is the sustainability could be impacted by outside factors like
Definitely.
temperature, weather, perhaps even the conditions inside of the factory. Maybe have a breeze, and that could cause some of the elements to move a little bit.
Probably, yes. But as I said, right, I mean, those could be slight, deviations or slightly off the mark, but then largely most of it is still real time, still quite accurate, and it lets you monitor all aspects like end to end, right from how you procure your source material, your supply chain, your inventory, your production processes itself, your packaging, and right to your transportation to your retail outlets, your end users, consumers. So just imagine a system where you are able to do a digital twin at a supply chain level, at an inventory level, at a factory level, at a machine level, at a procurement level, and at a distribution level. And once all these channels are interconnected and you are well informed of the bottlenecks, of expected arrival times of your shipments, and what if something fails and how to intelligently reroute it, that's when it makes your manufacturing and your distribution channel more intuitive, more smart. And that is what makes you build the factories of the future, as we call them.
Yeah, that sounds really, really awesome. I'm really keen to see how the manufacturing is going to evolve over time. Thank you, Priyanka, for all this awesome interview.
My pleasure.
And everyone, thank you for watching. And we're here at SSW TV, NDC Sydney, having a great time, and hope you have a great time as well.